Hello friends, I Praveen Chobe welcome you once again to this session. In this session, I have brought the content for you, that is solution of second order ODE, ordinary differential equations, second order ODE by using fourth order RK method, that is Runge-Kutta method. So I am going to solve second order equations by using fourth order RK method. I have posted recently the solution of first order ODE by using fourth order RK method. Here I am using second order ODE and I am solving second order ODE, and the method which is used is fourth order RK method. So we need to understand friends once again, in fourth order RK method, we are using four constants. Those are k1 to k2 up to k4, that is k1, k2, k3 and k4. These four constants are to be used. The formulas for fourth order RK method are like this. So for understanding that, or the difference between the formulas of previous method and this one, what are those? Let us see. Let us try to understand. First of all, second order equation, that is second order ordinary differential equation, second order ODE, is given by d2y by dx square. d2y by dx square is equals to y double dash. It is represented with y double dash, and hence we need to again consider this as f dash of x comma y. See, if you remember, previously we have said, or in previous first order equations, if you go through my videos, we have written as f of xy. Previously we have written f of xy is equals to dy by dx. This dy by dx is nothing but y dash. So if I am taking f dash of xy, that is y double dash, and that is nothing but d square y by dx square. So same thing friends is mentioned here. Z is equals to y dash, that is z is equals to y dash is considered. Once again, if we see the second order equation represented, d square y by dx square is equals to y double dash, which is f dash of x comma y. The next step is to calculate values of k1, k2, k3 and k4. So k1 is equals to, k1 for this case is equals to h into f of x comma y. k1 is equals to h into f of x comma y comma z. This is the value of k1. It means your function f of xy, which we were considering up till now, that can be now xyz, that can be a function of x, y and z in second order. Okay, and out of which what is that z, that also we are going to see. Here z is equals to y dash, which is nothing but dy by dx. Generally friends, if you consider any second order equation, second order ordinary differential equation, that is d square y by dx square plus some term dy by dx plus some other term is equals to 0. Likewise we will be considering the second order equation. So I have considered this term dy by dx is equals to z, and hence we could say in this equation k1 has become equals to f of x comma y comma z. Z is equals to y dash, that is dy by dx, and therefore if I take one more derivative of it, that becomes y double dash, which is d2y by dx square, and that is nothing but dz by dx. Representation of y double dash will be dz by dx. if you have understood that, then next part is to calculate the value of k2. So k2 is equals to, friends, k2 is given by k2 is equals to, the formula is h into f of x0 plus h by 2, comma y0 plus k1 by 2, comma z plus l1 by 2. Here see, if you compare the previous method where we have used fourth order RK method to solve first order equations, in that method these two terms were only there in the formula, that is the term of x0 and y. These were the only two terms there. Here this z term is added, and why it is added, that we have understood, that we have seen just now. Okay, third parameter is added because z is the derivative of y term that we have considered, where L1 is equals to h, several times L1 is equals to h, or it is depends upon the conditions, those are given in the problem statement. So generally the second order differential equation will be given by d square y by dx square plus dy by dx plus xy is equals to 0. Here this term is z, so that is why it is said the function is f of x comma y comma z. It is function of xy, and also z term is present there. Initially x is equals to x0 we need to consider, y is equals to y0, and dy by dx value should be considered equals to z0, means initial value of z. Then further d2y by dx square can be considered as dz by dx. Why I am saying this? See, z is equals to dy by dx. So if I am calculating d2y by dx square, that is given by dz by dx. Same thing is written here, same way the equation is written. Then we need to write the equation into the standard form, such as dz by dx plus z, where z is nothing but dy by dx plus xy is equals to 0. Then from that equation it is written into the form such that dz by dx is equals to z plus xy. On the other side, negative sign will be introduced. From this equation I am writing, this z and xy term is taken on other side, so it becomes minus in bracket z plus xy dz by dx. And if you have written that, then we could say dz by dx is the function of xy and z. Here z you need to consider, z is nothing but z is equals to dy by dx. Then only you can understand this is representation of second order equation. So let us use this method. Rest formulas are same to calculate k1, k2, k3 and k4, all the formulas are same. So let us try to understand this method for solving the problem that is given by first problem statement. See friends, first problem statement that is going as solve y double dash is equals to x comma y dash square comma y square. This is the equation given. Y double dash is equals to x y dash square minus y square. This is the equation we are supposed to solve for x is equals to 0.2. Correct up to 4 decimal places. Initially x0 is equals to 0, y0 is equals to 1. This is the initial condition given, and one more thing is given, that is y0 1 is equals to 0 and h is equals to 0.2. These are the things given. So let us start very quickly with the given data, what is given in this problem. See, I have got y double dash is equals to x comma y dash square minus y square. This is the equation given to me. This equation y double dash, I am saying I need to understand y double dash is nothing but d2y by dx square is y double dash, right? Double derivative of y with respect to x. So that is d2y by dx square. So y double dash is equals to d2y by dx square is equals to, what is that? X comma y dash square minus y square. This is the equation given to me. And few more things are given. What are those? x0 is 0, y0 is 1, y0 dash is 0, and h is equals to 0.2. H is equals to 0.2. These are the things given. So let, first of all, z is equals to dy by dx. Still I am trying to understand what data is given, and I am trying to represent it in the form I want. Okay. We know z is always equals to dy by dx, that is derivative of x in second order equation, second order ordinary differential equations, to be very specific. And this can also be represented as y dash, as it is derivative of y with respect to x. I can say this is y dash. Same thing is written here, z is equals to dy by dx, that is equals to y dash. If I consider this as y dash, then y double dash can be written equals to dz by dx. Y double dash is equals to dz by dx, and hence the equation of y double dash can be equated to dz by dx as mentioned here. So dz by dx is equals to x, then this y dash square term is written as z square. How it is so? Again, you need to understand, friend, z is equals to what? Dy by dx, which is equals to y dash. So this dash term is nothing but dy by dx, and it is represented as z. So if I represent the equation in standard form, dz by dx, y double dash is equals to dz by dx, I could write that is equals to x into z square minus y square. Why I have written this? This is very important to be understand. See, this was the previous term. In this term, there was one term represented y dash square, out of which, friends, y dash is what? Is dy by dx, and dy by dx I am going to consider it as z. So if it is y dash square, I can say this is nothing but z square. So if I put that value here, I will get dz by dx is equals to x z square minus y square. This is the equation. Initially, y dash 0 is equals to 0. If y dash 0 is equals to 0, it means z0 is 0, because y dash is z. So y dash 0 is equals to z0 is equals to 0. And therefore, if I write this as dy0 by dx, that is equals to 0. This is nothing but y dash 0, y dash 0. Derivative of y0 with respect to x, that is y dash 0, dash is representing the derivative. Hence, meaning of all these three terms is same. All these three terms are same. So, starting with the procedure, number 1, step 1, f of xyz is equals to z is equals to dy by dx, right? Is equals to dy by dx. So that can be written as dz, that can be written further as g of xyz is equals to dz by dx, that is z square dot x minus y square. This is nothing but the same equation I have written. See, dz by dx, z term is taken earlier, z square x minus y square. So this is just the representation. Say, to represent this is function of f x, y and z. Okay. Then next step is to calculate n, that is number of iterations required. Number of iteration required is always equals to xr minus x0 divided by h. H is step size. So if I look at the problem statement, I have got the value for x0, I have got the value for xr. What is that value for xr? If it is asked to calculate the value of y, at x is equals to some value, that value is considered xr. So xr is equals to 0.2 in this problem. x0 is equals to 0 in this problem. So if I put all those values, h value is also given. So if I put all those values, I will get n number of iterations required. N is equals to xr, that is 0.2, minus x0, that is 0, divided by h, which is 0.2. So that is nothing but 1. So only one iteration is required to solve this problem. So let us perform that iteration. So in iteration 1, I could say k1 is equals to h into f of x0, y0, z0. Hence it becomes h value is 0.2, and f of x0, y0 and z0, if we check that values, we are knowing that in the given problem statement x0 is 0, y0 is 1, right? Then dy0 by dx is equals to 0. Hence we could say this term k1 is equals to h into f of x0, y0, z0, that becomes equals to h into z0. We have written h into z0, and from where I have got all these things, I have taken as, see, the being a part of standard procedure, I need to consider f of xyz. F of xyz is equals to z. What is z generally? Z is nothing but the derivative of y with respect to x, right? So z value I am considering. If I take this x0, y0 and z0, this becomes z0. Z0 value I know is 0, which is calculated here. Z0 is equals to 0. Hence here in step 1 I am getting k1, which is h into f of x0, y0, z0, out of which x0 and y0 term is not at all existing there, because f of x0, y0, z0 or f of xyz is equals to z from this equation. Hence I can say this becomes h into z0. If we put the value of z0, which is 0, we will get finally the answer k1 is equals to 0. Hence we need to understand k1 has become equals to 0. Then L1, what is L1? L1 is equals to h into g of x0, y0, z0, and which is written as, see, again I need to consider these two representations. See, this was the representation where we are calculating k, and this is the representation where we are calculating L. That is why I have written here, friends, that is why I have written here 1 for calculate k, 2 for calculating the L. These two are the important things those we should note, or those are going to be a key in solving this type of numericals. This first term is going to be same for all numericals, and this is directly coming from the problem statement. Which is given. Okay, so we have derived it dz by dx from the problem statement, and that is why this term, I hope you understood this now. So L1, when we are calculating, L1 is equals to h into g of x0, y0, z0. That is becoming equals to, I am going to put the value of x as x0, y as y0 and z as z0 in this equation. I need to understand. So h value is as it is, h into z0 square dot x0 minus y0. This is coming from this equation. So if we put all the values, h is equals to 0.2, then z0 is 0, x0 is again x0 is 0, and y0 has a value, that is we could say 1. Y0 is 1, which is given in the problem. Y0 is equals to 1. See, here you can identify it. Y0 is equals to 1. Hence y0 is equals to 1. If I put 1 square will be 1, as this is y0 square term. So 1 square will be 1, so you can observe it neatly. H into z0 square into x0 minus y0 square. So this is 0, this is 0, and this is 1 square. 1 square becomes 1, so it is minus 1 square. 0.2 into minus 1 square. 0.2 is value of h, right? So it is minus 0.2. So if we got it, the value of L1, then next work is to calculate the value of K2, which is dependent on the value of K1 and L1. So K2 will be given as, K2 will be calculating here as h into f of x0 plus h by 2, comma y0 plus k1 by 2, comma z0 plus L1 by 2. So that becomes equals to h into z0 plus L1 by 2. So that is equals to K2 when we are calculating, that is equals to 0.2 into, see why I am doing this, why I have used this term only and why not other terms, you may get confused. So no need to get confused, friends. See, at the start only, here itself I have written f of xyz. F of xyz is z only for this problem. It is only z. Z is equals to dy by dx, it is, so it is only z. If it is only z, instead of z I am going to put z0, it becomes z0. Instead of that, if I am going to put z0 plus L1 by 2, so this value only I am going to put in the equation, and hence you don't find any term related to x0 and y there, but only z0 related terms. So h into z0 plus L1 by 2, h is known, that is 0.2, z0 is 0, L1 is calculated just now, that is minus 0.2, so minus 0.2 by 2, answer becomes minus 0.02. So minus 0.02 will be the answer. Once we got K2, next work is to calculate L2. Now while calculating L2, we are going to use this equation, the equation which is shown here, z square dot x minus y square. In this equation, instead of z, you need to put z0 plus L1 by 2. Instead of x, we need to put x0 plus h by 2. Instead of y, we need to put y0 plus k1 by 2. So if we put it in that equation, you will get, in this equation, if I am putting those values, this equation, so I will get L2 is equals to h in bracket, z square is there, so instead of z, z0 plus L1 by 2, this bracket square, plus x plus into x0 plus h by 2 minus y0 plus k1 by 2 bracket square. That is how this equation, z square dot x minus y square, this can be represented here to calculate L2. So after putting the values, we will get L2 is equals to minus 0.1998. Then we will be calculating K3. So to calculate K3, the formula is K3 is equals to h into f of x0 plus h by 2, comma y0 plus k2 by 2, z0, comma z0 plus L2 by 2. Again, we need to understand K3 is going to become, K3 is equals to h into z. This is the actual value of K3. Instead of this z only, we are putting here z0 plus L by 2 or z0 plus L2 by 2. So if we put that value, we will get K3 is equals to minus 0.1998 after putting the value here, h value and z0 L2 value. After putting that, we'll get it. Same way, we'll be calculating L3 value. So L3 is going to become, now we know how to calculate L3. L3 is going to become, the formula is h into g of x0 plus h by 2, comma y0 plus k2 by 2, z0 plus L2 by 2. We could use the equation which is given above, that is this bracket is representing the equation. What is that equation? Z square x minus y square. This is the equation. This is value of z square x and y square. So instead of that x, y and z, we are using z0 plus l by 2 square instead of x, x0 plus h by 2, and instead of y, y0 plus k2 by 2. So if we put all these values z0, l2, x0, h, y0, k2, we'll get L3 is equals to this much. Same way, we are calculating the fourth value, that is k. So k4 is equals to h into f of x0 plus h, comma y0 plus k3, comma z0 plus l3. Out of which, when we are calculating k, we need to understand for k, the equation is k is equals to h into z. So instead of z only, I am going to use z0 plus l3. So if I put the value of h, z0 and l3 here, I will get k4 is equals to minus 0.03916. The next work is to calculate L4. L4 is equals to h into g of x0 plus h, y0 plus k3, z0 plus l3. So in the equation, z square x minus y square. In this equation, I'm going to put z is equals to z0 plus l3, x is equals to x0 plus h, and y is equals to y0 plus k3. Hence, after putting the values, I will get L4 is equals to minus 0.190552. Next work is to find out the value of k. So we are calculating the value of k, that is 1 by 6 k1 plus 2k2 plus 2k3 plus k4. So all these values are known to us now, we have calculated them. When we put all these values, you will get k is equals to minus 0.019853, and L is equals to 1 by 6 L1 plus 2 L2 plus 2 L3 plus L4. Same way, similar to k, the formula of L is there. So L value also we have calculated. Then once we have got the value of L and k, our work is to calculate the value of y and z, that is step 6. So we have calculated yr is equals to y0 plus k, that is 0.98014, and zr is equals to z0 plus l. L value just now we have calculated, z0 is known, that is 0. If we put that, you will get this. Hence, finally I could say, when x is equals to xr, that is 0.2, zr is equals to yr dash, that is derivative of this term, which is equals to minus 0.19696. zr, which is derivative of yr, is equals to minus 0.19696. This is how we are using the fourth order RK method for solving the second order ordinary differential equations. This method is little bit complicated, but still I have tried explaining it. If you go through the first video, where the previous video where I have shared solution of first order ODE by fourth order RK method, if you understand that, then only you can identify the differences between previous method and this one, that is solution of first order ODE and solution of second order ODE. Once you understand that difference, then this will be very easy for you to use this method. So with this, I stop here in this session. If you have understood implementation of fourth order RK method for solving the second order ODE, I request you to please like this video and please subscribe to this channel for future videos. Thank you very much, friends.